Hello everyone, this is Amrita, your IB Maths educator. This is my class 1 where I am going to discuss binomial and normal distribution, and this is a part 1 of my class 1 where I am going to discuss binomial distribution along with the GDC tricks. Okay, let's start. So in binomial distribution, you just need to remember few things. First of all, I want to tell you that there is some difference between, there are two kind of distribution, discrete distribution and the continuous distribution. So in discrete distribution, we are talking about the point-wise values like probability x is equal to 1, probability x is equal to 2. But in continuous distribution, we are talking about the intervals, right? So suppose if we need to find out the probability between 2 to 5, so what we need to take in discrete distribution, just we will add those probability at x is equal to 2, probability at x is equal to 3, probability at x is equal to 4, and probability x is equal to 5. But there are infinite number of values lies between 2 to 5. Therefore in continuous distribution, we just need to integrate from 2 to 5. That's it. Okay, so binomial distribution is a discrete distribution. Now, how you will identify in the question that whether we will apply binomial or not, right? So for binomial, you just need to remember that you must have fixed number of trials. Like if you are tossing a coin 5 times, so 5 times is a fixed number of trials, and each trial only two possible outcomes are there, right? So two possible outcomes, either head or tail. So suppose if I am considering head as a success and tail as a failure. Okay, so probability of getting head in each trial is representing as a probability of success, and probability of getting tail in each trial is taking as the probability of failure. Okay, so that means the first point is very important, that is fixed number of trials, and second, only two outcomes are possible, success and failure, and third one is the probability of success remains constant in each trial. That means suppose if the probability of success is 1 by 2 in first trial, then it should be constant in all 5 trials. Okay, therefore the trial should be independent. And one more thing I need to add, that the number of trials is represented by n, and the number of probability of success represented by p, probability of failure represented by q. Okay, so this is the NCR, p to the power r, q to the power n minus r. What is that? This is nothing but the probability distribution function for binomial distribution. Okay, so suppose if we need to find out probability x is equal to 3, you can see this example also. So I am tossing a coin 5 times and I am representing head as a success. Okay, so you know that the probability of getting head is 1 by 2. Okay, so n is equal to 5, that means 5 trials, and the probability of success 1 by 2, which is same in each trial, right? Now probability x is equal to 3. So what we need to find out, we just need to find out the probability of getting rth success in the fixed number of trials. That means we need to find that out of 5, find the probability that we are getting 3 times success. Okay, so out of 5, that means 5C3, and we are getting 3 times success, that means p to the power 3, because p is the probability of success. If we are getting 3 times success, that means 2 times we are getting failure, right? So q to the power 2. Why? Because q is representing the probability of failure. So one more thing, that you need to just remember this formula, because that is not given in your formula booklet. You just need to remember for the paper 1, otherwise it's not required for the paper 2. Just few notation you need to remember for this binomial distribution, that we write it like x distributed. So we will write x, this sign we use for distributed, binomial, and two factors, n which representing the number of trials, and p which representing the probability of success, and e of x is nothing but the expected value or expectation, and Vx is nothing but the variance. Okay, and expectation formula is NP and variance formula is NPQ, or you can write NP1 minus P. right? And these all formulas are given in data booklet. Now for GDC, you need to just remember these 2 points. When you need to find the probability for exactly 1 point, then you need to use binomial PD. And if you want to find out for greater or equal to 3, so you just need to use inequality if there, then you need to use binomial CD. Suppose for the same example where we have n is equal to 5 and p is equal to, see, p is equal to 1 by 2, and we need to find out probability x is equal to 3. So how we use this by GDC, this I'm going to show you that how we use GDC for it. Okay, as you can see the GDC software on the screen. So first what you need to do, just go to okay, there are two ways to solve. First I'm showing you the first one. First you need to just go to the distribution. If you will see, you just need to go this distribution, wait a minute, yeah, distribution. Okay, then we just need to choose, yeah, okay, execute, and then we will choose the binomial, the first one, the binomial, and we know that it is equal to 3. So for equal to 3, we you choose this trail, okay, exactly 1. So now for the x value, what we will take, we need to find out at 3, so we will write 3. And for the number of trials, how many number of trials we have, the number of trials we have 5, so here we will put 5. And what is the value of p? The value of p is 1 by 2, right? Now we will press execute. Okay, so we will get the value as 0.3125. Okay, and you will see that this is a pointwise graph and it is also discontinuous. Okay, so these all the values are on the pointwise. Okay, so now if you need to find out for probability x is less than 3. Okay, probability less than 3 means we need to choose left tail, right? Left tail, or else I can write this is nothing but probability x is less or equal to 2. So for that, what we need to choose, again we will go to binomial, then this is what, this is left tail, so this we choose for left tail. And next x is same, because we no, not x is same, now x will be 2 because we are interested for x is less than 3, right? And the number of trials are same and p is also same. Now we will execute. So for the probability x is less or equal to 2 is 0.5. Okay, now can you tell me, can you find out the probability x is greater or equal to 4? Okay, probability x is greater or equal to 4, so what it will be, so this is nothing but the right tail. How we will solve, so again go back, exit, we will press exit, go back, and again execute. It's a right tail, right? So we will choose this right tail, and the value, now the x will be 4 and number of trials same. Okay, and p is 0.5, so I'm getting it as 0.1875, right? So it is very easy to find out with GDC. Now I'm going to show the different method to find out. For that, you just need to go this statistic option 2. Okay, then go to this, press F5 distribution, then press binomial F5. So as I told you that it is x is equal to 3, so for this we will choose binomial PD, right? I told you, see, for exactly we choose PD, binomial PD. So for that, we will choose this binomial PD. Then we have a variable. Instead of list, we have a variable, okay? And at which value? At x is equal to 3. And number of trials? Number of trials are 5, right? And what is the value of P? It's nothing but 1 by 2. Okay, now execute it. See, you are getting the same answer, right? Now I will try to find out this probability x is equal to x is less than 3. So for inequality part, I told you instead of PD we will use binomial CD, right? So for this we will use binomial CD. Okay, so again we will go back. Now we will choose distribution, binomial CD, variable. Now see, they will ask you lower and upper point. So for this, what is your lower value? The lower value is 2 or something else. The lower value will be 0, because is it possible na ki you will get no success. Okay, so lower value will be 0 and the upper value will be 2. Okay, so for the lower value I am choosing 0 and the upper value I am choosing this 2. Okay, and this will be same. See, you are getting the same answer, right? Again for this, again inequality, so we will choose binomial CD. So distribution, binomial CD. So now for this, your lower value is 4 and the upper value is what? Because the how many total number of trials? Total number of trials are 5. So it will not exceed 5, right? So the lower value, okay, wait a minute. So for that, the lower value is 4 and the upper value will be 5. Number of trials are 5. P will be 5. See, it's totally matching your value, right? So I hope you understand all these concepts as well as the GDC operations. Thank you so much and stay tuned for the next video.